Since school started, I've been trying to find cool things to build to pass the hours of spare time I had. And one of the coolest things I saw on the internet was making a drone from scratch, with all the components in it like a camera and motors. So I decided to build one for myself. There are many YouTube videos online explaining how to build a drone, but in this video I wanted to make sure to explain every little step of the process so that you could do something similar yourself. Before I explain the materials I used, I'm going to explain how a drone actually works. The type of drone I'm making is called a quadcopter, hence it having 4 motors on it. As you can see, it's rendered here. A drone typically has 4 channels which control specific parts of movement for a drone. The first one controls horizontal movement. The second one controls the 2D rotation of the drone. The third one is called the throttle, which controls the power of how high it's gonna go. And the last one controls sideways rotation, allowing the drone to actually move from point A to point B. The next part I would like to show is the motor speed. As you can see, each of the channels asynchronously changes each motor speed, allowing for high precision in the movements we want the drone to imitate. This allows our drone to fly super fast or really high in the air. Now on to the parts. To make a drone, you surprisingly don't need too many parts to complete it, but there are a few essential items you need before you start to construct one. To make a drone, you require ESCs, motors, propellers, a frame, a flight controller, and finally some kind of power source, in this case a battery. Each one of these parts can be bought for different prices based on the specs, so you might have to research on your own. Regardless, the first one I'm going to explain is the ESC, since it's the most simplest to explain. An ESC stands for Electronic Speed Controller, and it's what controls the motor speed. A good analogy I came up with is to think of an ESC as some kind of wheel that you can rotate. The wheel starts off with a frequency of 0, and ends off with a frequency of 1. As you can spin the wheel, the frequency changes from 1 to 0. The ESC can change these values based on the joystick position on your controller. To visualize this, imagine a smart lamp in a dark room that can change its brightness. Inside this lamp, there is a chipset that functions in the same way as an ESC, and it can adjust the brightness of the lamp based on the digital output from the chip. Now, if we bring back the wheel from earlier and rotate it, it will adjust how bright the lamp gets. If it's 1, the lamp will get brighter, and subsequently, if it's 0, the lamp will get dimmer. And this is exactly how an ESC functions. This is an ESC connected to a drone. It has 3 cables that extend out into the motor to adjust its speed. The next part of the drone to look at is the battery. The battery powers up the entire drone. The obvious choice for the battery in this case is a LiPo battery, which stands for lithium polymer battery. This battery is the perfect for a drone, as it contains a large amount of energy in a small space. Here's the LiPo battery that I use while flying my drone. It's pretty small and probably only weighs about half a pound. It is a 4S battery, meaning it contains 4 cells of 3.7 volts each. The next part of the drone is the flight controller. The flight controller is essentially the brains of the drone. This is where all inputs are taken from the transmitter and interpreted to fly the drone. In addition, this is where the drone learns to self-stabilize itself. The way a flight controller works is by artificial intelligence and machine learning. The application of those things that I used is something called a neural network. A neural network is a web of neurons and weights that we use to train a brain. Think of it like a baby's brain that at first doesn't know anything, but over time starts to learn and gets trained based on its environment. The design of a neural network is actually inspired by how we think an actual brain sends data through neurons. The way a neural network works is through weights and layers. Each layer has a random number of neurons, and each neuron has a certain weight applied to it. As data get passed through the web, the neuron that it passes through will multiply the data by the weight, and get a final result. By assigning a goal for the neural network, the way it learns is to tamper with these results to get the final result that we desire. By changing these numbers in different ways, the neural network learns different things until it finally masters the skill. So after that, I spent a few hours to create the neural network code to control the drone. After a few days of training it, I finally got it to work, and now it properly self-stabilizes itself for me. In addition, I also implemented a failsafe, which brings the drone to the ground just in case the drone loses connection to the remote. This is super useful just in case the drone flies too far away from me, and I don't have to worry about it flying away completely, and I can just find it on the ground. The next part to look at is the drone's communication, especially how it communicates between a controller. Effectively, this is known as a transmitter and receiver pair. In this case, a transmitter being a radio controller and the receiver located on the drone. A transmitter and receiver work by sending signals through radio waves and then interpreting that data into an action. The main use of this is the joysticks, where you adjust them and move them around, and then they send data to the drone and move the drone in the ways that the joystick predicted. Joysticks control the aforementioned 4 channels of the drone, allowing for faster movement. In addition, this is where you implement all of the extra things you want to add, such as a failsafe and etc. Here's the receiver on the drone that I used. It has a section for 4 channels as well as 2 additional channels that you can use for other actions if you want. The next part I would like to discuss are the propellers on motors. Propellers really come in 2 different models, 2 blades and 3 blades. For this project I chose 2 blade propellers, and there are a couple reasons for this. But first let's look at the pros of each model. 2 propellers tend to spin faster and have less drag in the air, while 3 blades tend to have higher thrust off the ground. Because we are trying to build a drone that isn't necessarily designed for racing, 2 propellers is the way to go. To check this out, I created a 3D simulation to show this. I created 2 different drones, one with 2 blade propellers and another with 3 blade propellers. As you can see, from a vertical bird's eye view, if I move the drones horizontally at the same propeller speed, you can clearly see that the 2 blade propellers fly much faster than the 3. But there is one more thing that we can check out, and that is thrust. Thrust is essentially how far up something can go. And as you can see, the 3 blade propeller has higher thrust, as it goes much higher with the same propeller speed. However, since we are looking for something that is smoother flying, we are going to go with the 2 blade propeller, as in the simulation it had way less drag. So now I'm going to show you the rest of the parts that I didn't show already in the video in real life. This is an example of a 2-blade propeller. It's pretty small and has wing flaps on the opposite directions. This allows air to get pushed down, and because of Newton's third law, the drone subsequently gets pushed upwards. In addition, each pair of propellers has the flaps in different directions. This is so that the drone doesn't drift away in only one direction. This is an example of a motor. This specific motor is called a brushless motor, meaning that it is used an electromagnet in the middle, as opposed to brush motors which have a permanent magnet in the middle, making them way more efficient and faster. These motors are used a lot in drones because they apply more speed and are way more efficient. This is a carbon fiber sheet, and this is primarily what we use to construct the frame of the drone. It is used because carbon fiber is ridiculously tough and strong, and also is extremely light, meaning you don't need to buy extra efficient motors to fly the heavier drone. This carbon fiber sheet doesn't even weigh half a pound, thus noting how light it is. So now you take all those parts, put them together, and finally you have a fully completed drone. I'm not going to fly it now because it's snowing, but I'm going to show you some footage that I flew the drone in during the summer.
that fast?